Hello. Today the topic is about dipole antenna. Now, before that, I have to say what is an antenna. Antenna is a device which is basically used for the communications of wireless signals. That's why the electrical part which are basically carrying the electrical signal are transformed to electromagnetic one in the first phase or in the electric medium and in the transmitter end, and the other hand on the receiver end the vice versa, that is actually the electromagnetic signal will be converted into corresponding electrical ones and it will be carried through the electrical wire. Sometimes the all antenna may not be in electrical forms. Today there are different types of antenna are also there. They are sometimes in dielectric antennas, sometimes in metallic slotted like a lossy waves antennas. Even today the most interesting part is that the microwave antenna part is there, which is basically the combinations of the dielectric and the metallic part. So the whatever may be the material used for the antenna, its the basic purpose is that to transfer or to I can say to the conversions of electro signal to electromagnetic ones and the vice versa. The first thing you have to know that how electrical signal are basically converted into the electromagnetic signal. That are coming from the Gauss's law of electromagnetism. The Gauss's law of electrostatics is basically say that divergence of E is basically rho by epsilon 0. It means whenever the electrical charge is there, either it is the static or whatever the form is there, the dynamic or whatever they be, the electrical field associated with these charges will be out of normal, the flux will be out, that is acting as a source if it is a positively charged particle. And in the other way, I can say in the other way, in the negative charged particle, these divergence charges will be converged, so it's known as the thing. So we can say the electrical charges are coming from the electric flux basically. They are coming from the charges and it will be goes either to the infinite or in the nearby negative charges to terminate. So in that way we can find a line of force. By this using the line of force is basically can carry some signals or some information you can transmit from one to end to another end. But the thing is that is the second law of basically the third law is say the Faraday's law of induction, which is actually tell the time varying if the time varying magnetic field is when it is generated, so therefore the electric field also has to be coming up. And the Ampere's law, before that the Ampere's law is also says that the electric current or the electric field when propagated there will be an associated magnetic field. Of course the conductor will be there. So if it is not even in the conductor, so therefore this displacement current, that is del E by delta T, which is the fundamental part of this of this electromagnetic wave signal, because this current or the mu 0 into J, which is known as the conduction current, is being present in the conductor, and in absence of the conductor there will be some displacement current, and this is the fundamental aspect why the electromagnetic signal can propagate without the electrical conductor, and it will be generated the curl of E. That's why the electric field are associated with the magnetic field. If the electric field are going there, according to Ampere's right hand rule, the magnetic field will be like this way, it will be like that way, like this is the upward direction, it will be in like that anti-clockwise direction, it will be rotated because the curl of B. And the same time, this field, if the electric field is a time varying, so therefore I can also see that this generated field may also going to be a time varying one, and that time varying field, magnetic field, also generated some electrical field is there. So vice versa it will be going on, and one axis is the indicated as one axis indicated for the electric field, another perpendicular axis indicated for the magnetic field, so direction of propagation will be the another perpendicular direction. That is, if one is E for the X direction, another is B for or H for the Y direction, therefore the directions of propagation will be always in the Z direction. And that's another interesting thing. The Gauss's law of electromagnetism is magnetism is so that the divergence of V is equal to 0. It means actually it shows that the non-existence of the magnetic monopole. It means electrical, unlike the electrical field, the magnetic field always closed loop in nature. So whenever the electric field are going to be generated, the associated magnetic field will be always in closed loop is there. As it is in the closed loop, and therefore if the electric field are going even outside the conductor medium because of the presence of the displacement current, therefore I can say the electromagnetic field in as a whole can be propagated even there is not presence of the conduction current. That means if not present, then this dielectric, that is epsilon 0 and the mu 0, that is the permeability of the medium, whereas the permittivity of the medium leads to the propagation of the electric field and association of the magnetic field, and this known as the propagation of electromagnetic wave even in the absence of the electrical medium. And that is the fundamental aspect how the electrical wire, that is the antenna, can transmit the electrical signal to electromagnetic signal. And in the opposite direction, in the receiver end, these processes are taking place just in opposite process, that is electromagnetic signal will be converted to electrical signal 1 and it will be going to be present received to the receiver end. Today myself, Samit Chakravarti, is going to present just overview of this kind of dipole antenna. The Ampere's law in electrostatics. It is the law which is basically tells us how the magnetic field is generated for the flowing of current inside the conducting medium. So inside the conducting medium current means the current is basically conduction current. So we have to form the fourth law of electromagnetics, that is the Maxwell equation. We have to tell him that only this conduction current will be taken care of. That's why in the integral form it is comes as V dot dl equal to mu 0 into IH, whereas the displacement current are not taken care of here because it is only the current that flowing in the conducting medium. Therefore, this V dot dl is equal to, I can say, the mu 0 into IC, that is the conduction current is there. It means whenever a current is passing through a conductor, there will be a circular loop of magnetic field is associated there. And these magnetic fields are basically generated due to the flow of current inside this conductor. And if that current, if a current is in a loop condition, therefore if the current is coming outside there and another current is going inside there, so therefore the total magnetic field will be a closed loop integral as given in this form. So and also definitely this rule are as per the right hand rule, of the Ampere's law, and we can say that it is given in the next slide. Is there? I have to say that in the next slide, where it is explained that whenever the electric current are going in that direction, the magnetic field will be in anti-clockwise direction if it is going upward direction, and similarly another current loop is going in the downward direction, that is if in their downward direction the current loop will be in opposite direction, so the total current magnetic loop will be taken care, that is given in here. So from these two slides we have to say how the magnetic field are associated with the flow of electric current, and the total magnetic field due to the flow of electric current is given by the B is equal to mu 0 I into 2 pi r. This is the basic equation for how the flow of electric current will generate a magnetic field. And the next is we are coming the operations principle of the antenna. Previously we told that the antenna is a device which actually transforms the electrical current to electromagnetic one. That means whenever the electric current are flowing through this conductor, that is, I can say, the antenna. Therefore, the associated magnetic field will be there, and this magnetic field and the flow of electric field, when it reaches in the discontinuity medium, therefore this displacement current, that is a mu unit of psi of 0 into delta the delta t, will be taken care of, because in the absence of this conduction current, so it will be going to be again propagate outside the medium. So you have to show, we can ultimately find that this electric current will be generated the electromagnetic field. So the communication will be taken care in the transmitter array, and then the receiver end, this opposite principle is taken care of. When the electromagnetic field will fall into this conductor, it will be generate, I can say, the electric field, because this is a time varying field. So here also we can say from the third law of the Maxwell equation, which is basically the Faraday's equation, where the time varying electric field will generate the electric field, and therefore we have to find out the electric current will be flow inside the conductor. This is called the receiver end. So one times the antenna is in transmitter end, it will basically transfer the electrical current to electromagnetic one, and other end, when it is the receiver, it will be receive the electromagnetic radiation and transfer it to electrical current or the signals or the information carrying signal, whatever may be, and that is the basic purpose of the antenna. This basic purpose of the antenna is basically to transfer the electrical or the information in the wireless medium, that is, convert the electrical signal to electromagnetic one and the vice versa. So in the electrical model of the electronic model, the transmission line model, whatever you can say, is there are basically we have to find out the radiation resistance as well as the radiation resistance and the input impedance of the antenna, and he have to be matches so that the effective transmission of the signals or the voltage current in the terms of the signal can be taken care of. So we have to match in condition is another thing how the signal will be taken care of. So antenna has basically the three parts. One part is have to say that is it is a convert or to transfer the electromagnetic signal to electrical signal, and that is the wave propagations taken place in the free space, and actually it's in the next discussion will come that this free space resistance is near about 377 ohm, and this is the radiation resistance where the E field and the H field will be converted or at the end of this there, and so that we have to match in this there, and this radiation resistance should have to match the input impedance of the transfer where the signal will be taken care of, or the signal will be going there, that is for the transmitter, and the receiver for the receiver ended. So total matching system is how good enough is depend upon the efficiency of the antenna, how good the antenna is. Right now, anyway, if this electrical signal are going to be propagated, therefore we have to say that this antenna is going to be working principle of this antenna. Now we are taking this is as an issue. Here we can also find that in animation format that the changes of electrical current, because it's a time varying electrical current, so the electrical current are going to alter voltage, current or voltage are going to be changed alternately, and therefore the field will be generated, and this field will be associated with this electric field and the magnetic field. So the electromagnetic waves are going to be propagated, and for a particular frequency, that is why the lambda is remain the same, and that's why we have to say that this electromagnetic wave are propagated from the from this antenna, and the vice versa. When the electromagnetic wave are falling on this antenna, it will be also generate a time varying electromagnetic field, will generate a time varying current.